So good morning and welcome to the Clusterpoint webinar today. My name is Paul Gant. I'm the VP of Sales for Clusterpoint across Europe, and I'm joined by the CTO of Clusterpoint, Jurgis Orups, who will be assisting me in the session that we're running at the moment. So a bit of background first of all. We are running this, as you can see on GoToWebinar. I can see that the people we'd expected to join have been able to do that, which is great. As you'll probably have noticed by now, the people who are attending are muted. The reason for that is that it's just not feasible to have lots of different people speaking with all the background noise that would go on who are all attending. So the way we work this so that everybody can participate as they wish is that everybody is muted, but you'll see on your panel, on your system, there's a questions pane. So as we go through the session, if you would like to ask a question, please type in the question to the questions pane, and then towards the end of this session I will read out the questions that have been asked, and between Jurgis and myself we will try our best to answer those. For those people who want to ask more detailed questions, then we will run on for those who are wishing and able to stay after the 30 minutes of the webinar is completed, and we'll be able to answer further more detailed questions. And if there's just one or two people left, then we will turn the audio on at that point. Okay, so I think that's probably it in terms of the background to how the meeting will be conducted. What is the background to this? So database systems, they are difficult to demonstrate because they're tools, they are engines which sit behind the scene and power applications. So it's actually quite difficult in a general sense to demonstrate a database. So what we are doing instead through this series of webinars is demonstrating applications that we have built for Clusterpoint to demonstrate to people. And from my point of view, one of the most exciting of these is Wikipedia, where we have taken a complete extract of the Wikipedia English language database, rebuilt that in Clusterpoint, and then we can demonstrate really what you might call in simple terms a supercharged version of Wikipedia with lots of additional functionality. So that's what we're doing today. I think it's particularly interesting, but I'm going to start, if I can, just by talking you through one or two aspects of Clusterpoint so that you understand the context to what you're seeing in this session. So first of all, what is Clusterpoint? Well, we call it a hyper-performance database management system. For those of you who've been involved in the technical world for some time, you may know this as a NoSQL database, next generation databases. There are various terms around this sort of database, but it's the engine that sits in the heart of systems and provides the performance to deliver data to the different elements of the applications that are calling upon that. Clusterpoint can be termed as a database that manages data sets that are otherwise unmanageable. Now, this is to a large extent the definition of what you no doubt have heard as the term big data. So big data, in its broadest sense, refers to new technologies and techniques which have emerged to handle the volumes of data that there now are in the world and in many organizations, which need to be in some way managed, analyzed, and disseminated. Clusterpoint does that, and the points underneath there describe when this will happen. It's the growth of data, it's the situation whereby certain projects are now becoming unfeasible because the underlying engine of the applications is unable to deliver the data quickly enough. And this is causing certain business projects to stall. And in general, there is a move towards how can we leap over this hurdle and manage the high volumes of data and get value from that. And Clusterpoint sits at the heart of that industry shift. In terms of what sits at the core of what we do, there are three things that next generation databases seek to achieve. And these go under the headings of velocity, volume, and variety. Velocity is about the ability to handle a flow of incoming data, huge numbers of transactions coming in simultaneously from different sources into the database and being able to handle those without falling over. That's what we call velocity. Volume is the ability to handle sheer numbers of records, so many millions and into billions of records being handled within the database. And variety is about the spread of data within the database, so the different types of data, not just structured data, as is typically the case within conventional database systems, but other types of data, including free text data, where you've got large amounts of free documentation which has been entered, and you need to organize and sort that and retrieve that. Another example, such as geospatial data, where you know where things are on a map, and you want to then apply certain algorithms which will show you how do I get from point A to B via point C in the most efficient manner. That's an example of how geospatial data can be of use. So those are the core aspects that any NoSQL next generation database should deliver. But there are certain things that we have achieved with Clusterpoint which go over and above that, which are the unique facets which make this such a high performance, and as we call it, hyper performance system. So I think there's a couple that I want to pull out. The first here is transaction integrity. ACID is a bit of a detailed technical term, so let me not go into that. But the principle of this means that, as with historic relational databases, the databases that we've had around for the last 30 years, it is feasible to have multiple transactions coming in simultaneously and know that a transaction is either completed or is not. And if it's completed across all aspects of the system. So you don't end up at any point, there's no chance of ending up with a half-posted transaction. And the second thing maybe that's worth pointing out here is rapid development, that we have developed a system whereby the way that the developer interfaces with the database uses a subset of SQL queries, the SQL query language. That's really important for development teams to get up to speed quickly and be able to use the software without a high training curve. And then the third thing I'd like to point out here is the advanced processing features of Clusterpoint. This in particular is based around two aspects that I think are most important. One is built-in free text search and retrieval capability, which gives Google-like capability within Clusterpoint, and we'll be seeing that when Jurgis starts the demonstration. And we really also have built in recently the capability for joins. Joins will mean nothing to you unless you're involved historically in the database world, but that's the ability to take tables and join them in the way that you would do in a historic or a conventional relational database system. And Clusterpoint now has that capability, and that gives us great compatibility with the past world, particularly if you incorporate the SQL-like queries. So, taking those three V's, adding across the six unique features of Clusterpoint, we believe gives a unique capability of power and performance, and also then the scalability, the transaction integrity, the speed of development, the availability, and some of the advanced processing features. We think it makes Clusterpoint the most powerful tool in the market for this sort of application. And that's not gone without notice of the analysts, and Gartner have defined our platform delivery of Clusterpoint, whereby the Clusterpoint database is delivered as a service on a hosted database platform by ourselves, as qualifying us for one of the cool vendors of 2016, something we're pleased with as we progress our work in this area. Okay, so that's the commercial, that's the backdrop to Clusterpoint. Let's now move into the actual demonstration. I'm going to start this myself, and then I'm just going to hand over in a couple of minutes to Jurgis to really continue with the detail of this. And that will take us probably until about another 15 minutes from now, until 5 to the hour, and then we'll open the floor for questions. So here is the Wikisearch portal. All I'm going to show you here is what's all this doing. So what we did, in actual fact, this is some months ago now that we did this, so this is a snapshot of Wikipedia, but it demonstrates every aspect of this very well indeed. So we took a full, what we call data dump of Wikipedia, 15 terabytes. We also added to that some additional, what we call metadata, which comes from DBpedia. You may or may not have visited this site, but it adds further information on top of the Wikipedia database. We then put that through what's called an extract, transform, and load process. That just means we got it from A to B, and the A was the existing Wikipedia database, the B is the Clusterpoint database, and from that we created two databases. We created the database that we're primarily going to be looking at today, which is the actual articles from Wikipedia, and we'll be showing that, as I say, in a couple of minutes. We also, I think, fascinatingly for me, created a separate database of all the revisions that have taken place since Wikipedia was initiated. So you can see, in actual fact, the revisions are 140 gigabytes in size, whereas the actual size of the database is 40 gigabytes. So fascinating part of what Jurgis will be showing you is how we manage to bring those together. So on that note, as to how we got here, let me hand over to Jurgis to walk you through what it is that we can achieve using Wikipedia within a Clusterpoint environment. So let me just hand over to Jurgis. Jurgis, the floor is yours.
Thanks, Paul. Thanks for introduction, and thanks for handing over. Hello, everyone. I guess good morning, good evening, or good day, depending on where you are located. So my name is Jurgis Orups, and I'm CTO at Clusterpoint. And today I'm going to show you our portal called Wiki Search, which is publicly available. So everyone who are listening and watching on my screen actually can access this portal while I'm demonstrating. So that's public portal. And our idea about making this project was really to do two things. One thing was to make new experience working with Wikipedia data. So we didn't like just the Google search type of interface when searching in Wikipedia. We want to really improve that in different ways. This is one goal for us. Another was just to make it as internal project, also to demonstrate our database capabilities. So everyone who finds some similar functionality on your projects, you really can use it. So in a nutshell, Wikisearch is we wanted to make this Google-like experience on Wikipedia data. So you see the first screen, which is just an one input field where you can enter your search keywords. So let's start with something that we want to find in Wikipedia. So I choose to demonstrate for demonstration keyword John Lennon because recently he has some big birthday. So let's try to find out what's in Wikipedia about the John Lennon. So when I hit the button to make the search in Wikipedia, it actually made the search and did quite a lot of other nice things that you see on my screen. So with behind the scenes, actually there was a couple of things happening. This application was sending a couple of requests to database to generate a couple of things that you see here. One thing on the right side we call the facets. So they are dynamic categories, which is really added to the documents or articles of Wikipedia using DBpedia data. So these are really the DBpedia data that Paul was referring. So what it did, application searched for John Lennon and counted how many search results were found in category, in genre, or occupation, record label, and etc. So those categories are dynamic. So let's try to search a bit different keyword, and you will see that the categories will change. You see, I search for butterfly. So when I search for butterfly, there's a couple of categories in Wikipedia. It is an insect. It could be like a swimmer because it's the style of the swimming. It could be the person. So let's try to click swimmer. So we see Michael Phelps, which is a very famous swimmer, you know. So we can choose insect, and you will see insects, butterfly as a butterfly, and all those families and classes about the insects. So you see that those categories are really dynamic. So that's about those categories, or we call them the facets. So that all the queries that were sent onto the databases in kind of real time, the whole data that you see is not pre-aggregated. That's really the live data. Okay, and let's move to this interesting piece in between. This is we call the concept graph, and the concept graph is really about extracting concepts from search results. You can imagine that by searching John Lennon, we found 5,307 results in Wikipedia. So it means that John Lennon was mentioned somewhere in those articles. So one way to learn about John Lennon would be go through all Wikipedia articles. In this case, it's 5,000, which is kind of unmanageable. Another way how to look on the search results is doing it graphically, and one way is to look at as a concept graph, through the concept graph. And in the middle you see this is John Lennon. So yeah, he's the part of the Beatles. The Beatles were established in Liverpool, and Liverpool is a peace monument which is really kind of made because of John Lennon. So you see those nice connections between concepts here in this concept graph. And actually, I'm not really a big fan of the Beatles or particularly John Lennon, but it's very interesting that when I searched for this, I found this Yoko Ono and Ono band. So actually, I was not so good at it. I started to dig into and searching what is Yoko Ono, and I found this is the wife of John Lennon, and they created the Ono band, where the John Lennon and Yoko Ono was like a artist in this band. So you see that there's quite a lot of interesting information that you can gather, not just reading articles, but just looking in this concept graph. So in our database, it has built-in capabilities to drive such a concept extraction algorithms. And in the bottom part of the screen, you see the standard search results, where you see there is so-called snippets from the whole Wikipedia article. So the Wikipedia article is much more larger, but our database is finding most relevant place in the article to extract the snippet. So this is functionality which is built into our database. Of course, this is capabilities to go page by page and read and find information that you really want to see. Okay, then let's move to if this part of Wiki search is about the search, about data retrieval, about concept extraction, about some categories, then the next part of this Wiki search is about the analytics. So our database support not just unstructured data processing, but also is capable of doing real-time aggregations, which is very usable for data analytics. In this example, we move to the function we call history, which really shows how many revisions in particular article were created in Wikipedia since Wikipedia was created. So we can go to the very first version of John Lennon article, which was created on 2001, and see how this article was made, and see that the largest contribution was in year 2006. So we can go into this year, zoom into the 2006, and then we can see in which particular month there was contributions made for this article. So again, when I zoomed into the 2006, there were the query to the database to restrict all revisions for John Lennon for 2006 and aggregate and ask the database to aggregate data by month. So let's see what was really the first revision created for this article. So it turned out that in 2002, in February 25th, there was the first revision of article for John Lennon. So you can zoom in and zoom out using some nice JavaScript user libraries, user interface libraries, but but behind the scenes, they're literally the database which provided data to the user interface to draw it. Okay, then let's move on to the next type of analysis of Wikipedia, to relations. And you know that in Wikipedia, the articles are related or linked together through the so-called relations or references. So there is a John Lennon article which is linked with other articles. And all those links are stored into the database. And to draw this graph, there's a couple of set of queries which is sent to the database to retrieve the neighborhood of John Lennon article. And we can go really deeper and explore new connections or links between various articles. So here we can try to find a way how John Lennon is connected to the New York Times. So it's through the Vietnam War article. And so we can explore more, go deeper, Ronald Reagan, things like that. So this is a way also how to explore connected data. So if you have an application or the use case where you have the connections or links between your objects, so our database can provide the capability to draw that kind of data exploration technique. Okay, and another interesting part here is about we built so-called time machine, where we can restrict time period to see how relations were built at that particular time frame. So I'm here moving the slider back to check what relations were particular time range, and you see that at the very beginning there was not so many connections, and over the time they changed, they added, removed, and the way how they interconnected at the end. So this is interesting kind of the way how you can also visualize the data using our database. So, and the last tab here, what you can do with Wiki search is really to check what amount of contribution for each of author of this article was made for a John Lennon article. So this is again an aggregation in the database side, where we aggregated all revisions made by all authors of John Lennon article and calculated a percentage of the whole article content. So here we see that the biggest contributor here for this article was Andreas GDE, whatever is the name for that, and we can click on this and see other articles which were made by Andreas. So we see that he was also quite a big contributor to Cynthia Lennon. I'm not sure if this is a sister of John Lennon or some relative, but that's interesting to find that he's also contributing.
It was his first wife, Jurgis. It was his first wife.
Sorry. Yeah, as I said, I'm not really good at the Beatles and John Lennon, so I'm very sorry about that.
I was there at the time, you weren't.
Okay, then we can go to Cynthia Lennon and check out what was the creator for that article. And then we can also filter out by link count and things like that, and generate new data and new visualizations. Yes, so that's a very fast journey through the Wikipedia portal that we created, and I think you enjoyed it, and I think we have left five minutes, and then I'm handing over to Paul to answer the questions.
Great, thank you, Jurgis. I always find that fascinating, how many times I see it, so really appreciate that. So a couple of questions. We've got one from Sally and one from James. If I can first of all ask James's question, I guess that was the one that came in first. His question was, how long does it take to go through, this is a fairly technical question, to go through the loading process, in this case from Wikipedia into Wiki search, into the Clusterpoint database?
Yeah, thanks for the question. In essence, really, loading the data into the database is quite fast process, because our database is capable of ingesting data of thousands of records per second. So if you have the whole Wikipedia, which is about 5 million records, so time-wise, it's very small. However, the challenging part really here is about merging data from different sources. In this case, is from Wikipedia and DBpedia. So Wikipedia provide the data as XML dumps. So the amount of the data is quite large. So you need to download, uncompress the data, clean the data, merge data with DBpedia, extract some links and things like that. That's the challenging part. And how we made it, we created our own ETL or extract, transform, load pipeline or chain of the tasks, which we distributed across the cluster, and we achieved to process the whole data and load into Clusterpoint in about 4 days. So that's about time for us to load the whole Wikipedia data as you see in the wikisearch.net.
Okay, thanks for that, Jurgis. A question from Sally. So Sally's been very kind, saying it's an impressive demonstration that we've shown here, but asked if we could walk through a business scenario to understand the return on investment. So I think, Sally, if you really imagine the data we've been looking at here, if this was the data that was held internally within an organization, they may have lots of documentation, which you can imagine a pharmaceutical company, you can imagine a compliance situation, you can imagine an academic situation or a research situation whereby there's lots of documentation held which is being built up and stored over time, and the organization wants to be able to find links and explore that data to understand, is there something they can learn from that? This is broadly known as business intelligence. Now, there are plenty of tools around to deliver business intelligence. It's a whole world in itself. One of the things that Clusterpoint brings to that is that rather than having to derive the business intelligence from a separate, what might be called data warehouse, which is created from the main operational systems, Clusterpoint has the performance to handle all the comings and goings of the data as that data set is being built and run the queries at the same time on top of that. So what you were seeing here, for example, in our Wikipedia demonstration, whilst that was going on, were we running the live Wikipedia system, all the articles could be being entered, amended, changed at exactly the same time as we are running the queries on that database. So the return on investment, there are many different facets of this. Business intelligence is one of them, and I think that the Wikipedia database most closely relates itself to a business intelligence scenario. Others are just sheer performance of ingesting information. So if you recall, I mentioned the 3 V's earlier. One of those V's was velocity. And what the velocity relates to is the speed in which data is arriving. Now, people, no matter how many people you have around the world, find it difficult to outpace a database, or certainly within a corporation, find it difficult to outpace the ability of a database to take their input. But if you have a social media situation, and if you have machine-generated data, so increasing now with the Internet of Things, you have data coming in from different points from machines, small computers. Another example could be jet engines. So Rolls-Royce monitor the performance of their jet engines around the world. So that data is arriving in at a very rapid pace. And conventional databases struggle to just take it in. They just can't receive the amount of data that's being thrown at them. So they have to start splitting databases down into local databases, which means then you lose out on the ability to have a view of the whole. So there are really many business return on investment scenarios, we're very pleased to talk to you about that as a separate conversation. But I think there's probably more than we could go into those in today's scenario. But hopefully that's given you some idea of how this works. Okay, so I am conscious that we are now exactly on the 30 minutes. I've right now got no further questions in front of me. So I think it remains for me to say thank you very much for joining. I hope you found that to be of value. It's quite sort of difficult from our end. We've got to get every message that we think is important that you might want to hear in a 30-minute slot. I'm pleased to say we've done it. So thank you, Jurgis, for that. I think you stuck right to the 15-minute slot that came in the middle of that. So superb. Thank you for everybody very much for joining. And I hope to see you again in one of our future webinars. Many thanks. Bye-bye.